Hello, today's topic is about dimensional analysis and sometimes referred to as unit conversions. And shown here are pictures of instruments we humans use to measure things. And we always like to quantify things. Instruments were invented to accomplish this task. And shown here is the invention of very accurate analytical balance, which played a critical role in establishing the law of conservation of mass, and laid one of the really important piece of foundation for the modern chemistry. Here is the thermometer, here is the stopwatch, and here is the pressure gauge. So we have all these instruments, and how are we going to express the results for those measurements? And sometimes we refer those measurements as quantitative observations. As also shown here, 3.25, and it is 3.25. Let me ask, is 3.25 of what? So you have to specify, have to use a description for that, what actually you are quantifying, what actually you are measuring. In this case, it's meters. So now you know it's the length you are measuring. So for the first one will be the numerical value of the measurement, and the second one will be the unit. So from now on, any numbers in chemistry class, it's meaningless because it does not convey the proper message what measurements those numbers are referring to. So in science, numbers with no units do not mean anything. So it has to have numeric values, numbers plus unit. So historically, many measuring systems were developed based on different units. For example, the temperature. For temperature, you have the Fahrenheit, and we have the degree Celsius system, and also later on will be developed the standard unit called SI unit. For temperature will be the Kelvin. So they are all different systems, and they developed over different time, over a period of time, but there is a conversion between them. So there's a conversion equation for them, convert from the Fahrenheit, degree Fahrenheit, to degree Celsius, to degree Kelvin. So there's how to convert between different units, and what you want to see, like the example here is how many yards are there in 3.25 meters. So we measured, the last time we measured the length to be 3.25 meters, but someone wants to know how many yards will be equivalent to 3.25 meters. So the ones I'm going to teach you today is called the factor label method, factor label method, and sometimes known as dimensional analysis, and sometimes will be referred to as monkey bar approach. So this is a math protocol used to convert between different units if the conversion factor can be established, if the relationship is direct. We'll talk more about that later. So what you need is desired quantity, is what you want, and where did you start? What you start with, is it given quantity, and also the conversion factors. Let's take a look at these conversion factors. And conversion factors are value relationships or equities expressed as a fraction. So this is the one I'll show you. It'll be becoming clear if I show you the examples. So we know 1 meter is equal to 1.0936 yard. So that's the equality we're talking about, is 1 meter equals 1.0936 yard. So you actually mathematically you can rearrange it. You can divide both ends by 1.0936 yard. So you can actually have that. And also you can do the other way. You can divide both ends by 1 meter. So this one is 1.0936 yard. And those are the conversion factors. And also vitally important, and keep that in mind, I will mention it multiple times, conversion factors are always equal to 1. It will become self-evident at a later time. So we actually give you the examples for doing that. So actually for this relationship, you can actually derive 2 conversion factors. 1 meter over 1.0936 yard or 1.0936 yard over 1 meter. Both of them equal to 1, so both of them are conversion factors. So note, basic conversion factors based on equivalency relationship are always equal to 1. So this is why what we say is y equals a times f, a times x. So it's got a direct relationship proportionally. If you change x, and y will change proportionally according to the factor a. They generally come in pairs with 2 units trading places. So all these conversion factors, either you put this unit on the top or on the bottom of the fraction. Okay, so the steps involved in the factor label method, sometimes also to refer to a monkey bar approach. First, write down the given quantity units. And second, multiply given quantity units by ones. So mathematically speaking, they are equal. So you can always write in ones. You can actually multiply by 1. And mathematically, you can actually write that forever. So if anything multiplied by 1 will be equal to anything you start with. So then now you can start substitute ones with conversion factor, because remember, all those conversion factor equal to 1. And that's the one you use to eliminate unwanted units and achieve desired units. And then you, after you double check with the units canceling each other and finally arrive at your desired unit, you can complete the math. So, and here I use SB, so I call it the super penguin to highlight the approach. So the question would be, how many yards are in 3.25 meters, and note 1 meter equals 1.0936 yard. And what's the first step? First, write down the given quantity unit. So in this case, 3.25 meters. And second, and next, multiply the given quantity units by ones. And remember, anything multiplied by 1 always stay the same. So it's 3.25 meter equals 3.25 meter multiplied by 1 and Actually, the ones could go on forever, because mathematically anything multiplied by 1 still equals to anything. So now we have that 3.25 meter equals 3.25 meter multiplied by 1 multiplied by 1. So now we have 2 conversion factors. Both of them equal to 1, so we can actually use them, start substituting them in, about which one to choose. So the ones in the above equation could be substituted by those conversion factors. How? Here only one substitution is sufficient, but which one do you choose? As you can see, those are 2 conversion factors, 1 meter over 1.0936 yard, and 1.0936 yard divided by 1 meter equals 1. So choose the one that will cancel out the meter, because this, you start with the meter, you won't go to the yard. The meter is your given unit, the yard is your desired or / target unit. So which one's going to accomplish that? Because you started with the meter, and I better have a conversion factor with meter on the denominator, on the bottom, so I can cancel with the meter at the very beginning. Okay, so let's see now, and 3.25 meters equals 3.25 meters times this particular conversion factor, because I want to put meters on the bottom. So this meter can cancel with that meter, and I got my desired unit, the yard. So in this case, I use 2 checks to cross the meter out. So equals, finish the math, 3.55 yard. Okay, and in this case, bravo, mission accomplished. So you may have in your school or maybe in your elementary school math, you encounter those kind of problems, and you can see you use the proportionality approach for solving those kind of problems. No problem with me at all if you want to use that. However, those methods will limit your capability of solving really complex problems, which for those complex problems will require multiple steps. Keeping track of should you multiply, should you divide would become challenging, and this using dimensional analysis will help you tremendously. I do not memorize should I multiply, should I divide. In this case, the unit tells you how to do it. If you're really good at this, an equivalent but simpler protocol could be used. So this is the one we're going to talk about. It's called monkey bar. So you started with 3.25 meters. Now you draw these bars. You started here, and this is the vertical line. This vertical line is actually the equivalent, have a multiple sign, multiply sign between those. So you started with 3.25 meters, and you say I want to cancel the meter, so I put in the meter here and yard on the top. So now you know it's 1.0936 yard equals 1 meter, because so this whole term has to be equal. Otherwise, this equal sign is not valid anymore. Okay, so then you can cancel out the meter, and you got the yard. That would be the desired unit. So the answer is 3.55 yard. So let's take a look at example number 2, and here is a very challenging one. If you want to solve this problem in a traditional fashion, get the proportionality at each step. So you can note those conversion factors. 1 equals 7 days, 1 day equals 24 hours, 1 hour equals 60 minutes, 1 minute equals 60 seconds. So a little bit more complicated than example number 1, but the approach is the same. You start with 1 week, and now you start drawing those bars. You're drawing a long line and divide them into kind of compartments with those vertical lines. And it's becoming clear why I have to draw that. So you started with a week. So I want to cancel the week because that's the given. What I want to go is you end up with seconds. So in a sense, the week can only convert it to days with this conversion factor, because 1 week equals 7 days. And then you can take 1 day and convert it to hours. And in this case, 1 day equals 24 hours. And so the days cancel the week, and we cancel leave with hour. Now it's not going to be sufficient to answer those questions. And now you see I got to cancel the hours, but in this case, logically, I can only switch to 60 minutes. 60 minutes. Now you end up with the hours canceled, days canceled, week canceled, you end up with 60 minutes. Okay? And that's still not the target. So now you say 1 hour. There's a typo here. Then they should be 1 minute and 60 seconds. 1 minute, 60 seconds. 1 minute and 60 seconds. This one's a bit more complicated than example 1, but the approach is the same. So I just came back, I corrected this animation. So in this case, 1 minute equals 60 seconds. Now you can see 1 week. Week is cancelled with week. Days cancelled with day. Hours cancelled with hour. Minutes cancelled with minutes. You got the seconds. Each of those vertical bars separate out a conversion factor. 1 week equals 7 days. 1 day equals 24 hours. 1 hour equals 60 seconds. 1 minute equals 60 seconds. So now I start crossing them out. Week is out. Days are out. Hours and hour are out. Minutes and minutes are out. So then you can have the second in terms of the unit. That's your targeted unit. In this case, 4,800 seconds. So you just cross them out and multiply across. So the one we touched it upon slightly before is this metric system. And often the measurements, when we talk about the mass of the biosphere, and it's going to be exceedingly large. Or you're going to talk about size of a proton are going to be extremely small. So over the measurements return results of exceedingly large or small values. For example, is this 1, 2, 3? This is 2,345,000,000. 2 trillion. This how many dollars, and this is how many small meters, fraction of a meter for a subatomic particle, and we always say how to make scientist life a bit easier. So here comes metric prefix system. So if you have km, that means kilometer, that's a prefix, and this is actually with the conversion factors, and this is m, and that's a unit. It tells you it's in meters. You're actually measuring the length. And here's a big table about those metrics prefixes. You can see the prefixes. You can have, say, like centi, and it will be symbol, prefix symbol is c dash, and it's 10 to the negative 2, 10 to the negative 2. And deci is the 10th, deca is the 10, and nano is 10 to the 19th, micro is 10 to the 16th. Now you can see the conversion factor right around this, right around this table. Okay, right around this table. So the prefixes in red color need to be master result 8 of the table. So you have to say, gotta memorize those common ones. So the super penguin shows up again, and what does the numerical values associated with metric prefixes mean? It provides information regarding the numerical relationship between units with the prefix and units without the prefix. Okay, it's important. So in this case, it's 1 kilometer is equal to 10 to the 3rd meter, and it's always is you take the prefix k and you drop the k, and here is the equivalent. It's the equivalency. What I've been talking about. 1 kilometer is equal to 10 to the 3rd meter. Okay, so unit prefix and go to the unit without prefix. Without prefix. So the 10 to the 3rd, that would be the factor. So the conversion factors here is 1 kilometers divided by 10 to the 3rd meters, or 10 to the 3rd meters divided by 1 kilometers. Both of them are equal to 1. Okay? So the common strategy is convert a given quantity unit to unit without prefix, convert the unit without prefix to the desired unit. So factor labeling method could be readily applied to conversions between metric units. Because the relationship is 10 based and it's directly proportional. So in this case, let's see, 4 Tm equals how many? Nm, Tm, and Nm. So you can see 1 Tm, and I started with the monkey bars. I put 1 Tm here. So first thing I want to do is cancel the Tm, so it has to go to the bottom, and M with this, looking at that prefix table, you can only have a conversion between the Tm and the M, Tm and M. So it's 1 Tm equals 10 to the 12th M, but still, that's not what I want. What I want is I need to cancel the M and give me the nanometers. So you can put it in the conversion factor. It has 1 nanometers over 10 to the negative 9th meter. So in this case, it will be 4 times 10 to the 21st. 4. So the Tm canceled, the meter canceled, and you got a nanometers. So it's 4 times 10 to the 21. 10 to the 21. 4 times 10 to the 21 nanometers. Okay. So with this I end the measurement analysis podcast. Please go to the site and work on the worksheets so we can go over them in class. And thank you very much for your attention.